talk about the modulus argument form of complex number. Now we have known that if we represent the complex number in an Argand diagram, we can get them to look something like this. So the complex number, just like 3, 4. The complex number, it looks something like this. So this is our complex number, and this is the modulus of it. The modulus, which means the length of it from the origin. Now the modulus argument from a complex number looks something like this. So we have an r times cos of theta plus sine I times sine theta. So why is that this form? Now we have known that this will make a right triangle. So this is the right triangle with side length of 1, 2, 3 and 1, 2, 3, 4. The side length is 3 and 4, and thus we have this length to be 5. So that we can get if we have this length, we can actually get this length. So this length, so we have this length and we have this angle with theta. We can get this length. How? So this is theta. So this sine on this sine is equal to sine theta. And this is 5. So in this case, this is 5. So this is sine theta times 5. And that is denoted by I. And this length, this is 3. In this case, this is 3. But let's assume we don't know it. But we know the this length and this angle. So this over this is cos of theta. So that is equal to cos of theta times 5. Now this is the real part, so we don't put I in it. Now see, these had the same numbers of 5, so we have put 5 out. So this is cos of theta plus I sine theta. So the formula to show a complex number is by having, so if we have the modulus, the length of it, we put it at the top. So this is the length of the complex number, the modulus of the complex number. This times this length times so cos of theta. Now remember theta. Theta is the angle between the real axis and the modulus. Theta is the angle between the real axis and the modulus. This plus I sine theta. And this is what we call the polar form of complex number, or the modulus argument form of complex number. And from this, there's also different implications, such that we can find the tan of this being equal to this length over this length. In this case, this is 4 over 3. And we can also find, finding ways to find the modulus from this, having known this length and the angle. And we can also find this modulus, or if we know these two lengths, we can find the angle by using tan, and then finding the angle using tan. And from this formula, there's also a lot of implication from this formula, and that is basically the idea of the modulus argument form of a complex number. I just want to talk about the idea of how we can represent the angle differently. So let's say in this case we don't have we have 3 plus 4i, but rather we have minus 3 plus 4i. So that would be somewhere here. This angle will actually be bigger than 90. And I just want you to know that in this case it is still applied. So this will be theta, and it still applies because when it is bigger than 90, the cos will actually be minus. The cos will be negative, and third, it costs this this value to be minus 3. The modulus stay the same because 3 squared plus 4 squared is still 5, and the sine is still the same. So the case where the angle get more than 90 is stay the same, and also the case where it is say down here. So this is In this case, this is 3 and what is it? This case 3 and this is -4. So in this case, the angle is actually the negative value. So in this case, the angle here is minus theta is negative. In the case where it is down here or even here, theta is negative and it still works. In this case, it still works. The modulus argument from a complex number still works. So so it is the any angle that the complex number made with the real axis, that is what you will use in the modulus argument form of complex number.